I'm certified. Hello everyone, welcome to my YouTube channel. My name is Marvelous Pungo. Today we'll be doing integration. We will be solving few questions on integration. Integration is an important mathematical concept together with its inverse. Differentiation is one of the two main operations in calculus. In this lesson, we're going to focus mainly on definite and indefinite integrals by using different rules. By the end of this lesson, you should be able to evaluate both indefinite and definite integrals using different rules and properties of integration. By the end of this lesson, you will be able to integrate by using substitution method. Okay, we're going to have our first example. We're going to have x integral of x squared. Integral of x squared dx. We're going to have integral of x squared dx. Solving this integral, we're going to have equals to x to when you're doing integration, you add 1 when you're integrating. This is the first step. You add 1 on the exponent. Also, you divide by the exponent plus 1. And you shouldn't forget adding your C. Okay? So our final answer is going to be x cubed over 3. You can simplify it further by saying 1 over 3 x plus c. This will be your final answer. This is your final answer. So we're going to do our number 1 example. Our example is as follows. 1, number 1. We're going to have an integral of pi in x over x dx. So this is our first example. So integrating this one, you're going to use substitution method. Use substitution. We're going to let let u equals, let me write it properly. Let, yeah, better now. Let u is equals to in x. In x. Let u is equals to in x. In x, then our du, there is the x here. Our du is equals to differentiating in x is equals to the derivative of in x is equals to 1 over x dx. So basically we are solving for dx. We're going to divide this by 1 over x. 1 over x. Also this side, what you do on the right side, you also do it on the left side. Right? So our dx is equals to x du. This looks like k, let me fix it. It's x du. It's x du. So continuing, it's going to have, we changed our u is equal, our in x into u. So instead of writing in x, we're going to write u. So we're going to have this pi exponent u over x. We have the value of dx. It's the value of dx. It's this one. This is the value of dx. So instead of writing dx, oh, I made a mistake here. It's not supposed to be 3. Let me erase this. Instead of writing dx, we're going to write x du. We're going to write x du since we calculated our dx. Since we calculated our, so x is going to cancel x, and then we'll be left with pi to the exponent u. This is going to cancel this, and then we are left with pi, your integral of pi u du du. So integrating this, we're going to have pi exponent u over in pi. In pi. We are now integrating. That's why we are not including the integral side. So plus c. So this is going to be, this is not our final answer. Again, we said let u is equals to in x. So we have to replace our u with in x. We're going to, our final answer will be pi in x pi in x in x. This thing is giving me problems. But then, yeah. Our final answer would be pi in x over in pi. In pi plus c. This will be our final answer. This is our final answer. Now we're moving to our second example. In our second example, we have integral of e to the exponent 1 over x squared over x cubed. So in this example, we're going to let u equals to 1 over x squared. You let Okay, now we're moving to our second example. In our second example, we have integral of e1 over x. Now we're moving to our second example. In our second example, we have integral of e to the exponent 1 over x squared over x cubed dx. So in this example, we have to let u equals to 1 over x squared so that we can be able to differentiate. We're going to let u is equals to 1 over x squared. X squared. So then from there we can calculate du. du is equals to, before calculating du, we have to change this into a negative exponent so that we can differentiate simple. We're going to have x exponent negative 2. So differentiating x exponent negative 2, we're going to bring negative 2 down. Then we have x. Differentiating, you have to subtract negative 1 from the exponent. So we're going to say negative 2 minus negative 1, it will give us negative 3. Then dx. This is the value of our du. We are looking for dx. So before calculating dx, we have to change this. We have to change this negative 3 to be a positive exponent. So we're going to say negative 2 over x cubed. Now our exponent is positive. Then we don't forget to write our dx. Then from here we can be able to calculate dx. Okay, so in order for us to calculate dx, we have to divide by negative 2 over x cubed on both sides. Also this side we're calculating by negative 2 negative 2 over x cubed. So we're going to have our dx as let me move here. I'll continue writing here because I don't have enough space. So I'm continuing here. Our dx is our dx is equal to x cubed over negative 2. Shouldn't forget to write our du. Our du. So we're coming back to our equation. Since we said this one, since we said u is equal to 1 over x squared. So when writing our equation this side, you're going to replace 1 over 2 by u. We're going to have an integral of e to the exponent u, since we said 1 over x squared is equals to u over x cubed. Then we multiply by dx. We're supposed to write dx, but then we were supposed to write dx here, but then we're going to replace the x by x cubed over negative 2 du. So we're going to have x cubed over negative 2 du. So negative 3 and negative 2 are going to cancel each other. And then we are left with an integral of eu times 1 over negative 2. And then we write our du. For integrating this, we're going to have 1. Before integrating, we're going to have 1 over negative 2 integral of eu plus c. Continuing, we're going to continue here. Then we have 1 over, if you can integrate e to the exponent, and e which has an exponent, it remains the same, it doesn't change. So we're going to have 1 over 2, 1 over negative 2, 1 over negative 2 times eu plus c. 1 over negative 2. Right now we're going to replace our u by 1 over x squared plus c. This will be our final answer. This is our final answer. Okay, so now we'll be moving to number 3. Now I'm moving to number 3. Let me just create space so that you can be able to write our number 3. On our number 3, we are having trig ratios. Our third question, we have trig ratios. We're integrating trig ratios, so we have we have something common, 2x minus 1, 2x minus 1, meaning we're going to let 2x minus 1 equals u. Let u let u is equals to 2x minus 1. So deriving 2x minus 1, we're going to have du is equal to, deriving 2x minus 1, we're going to have 2 because this is a constant, so it becomes 0. We have 1 here. We're going to transpose this one down, then 1 minus 1 is equal to 0. Anything to the power of 0 becomes 1, so we are left with 2 dx. So now we have to calculate the x. We're going to divide by 2, divide by 2 on both sides. So after that, then we have our dx as 1 over 2 du. du. So we're going to come back to our equation. So we have the integral, then cosec instead of writing 2x minus 1, we're going to replace it by u. We're also going to do the very same thing on cot. We have our cot open bracket u, and then dx. Instead of writing the s, we're supposed to write, again, we have the value of the x right now. So instead of writing the s, we will write 1 over 2 du. 1 over 2 du. Then after, we have to integrate. We'll have 1 over 2. Integrating cosec multiplied by cot, it changes into negative cosec integrating cosec times cot, it changes into cosec, negative cosec. Negative cosec open bracket u. Let's see. So our final answer is going to be 1 over 2 cosec negative 1 over 2 negative 1 over 2 cosec this thing is giving me trouble. Negative 1 over 2 cosec. Instead of writing u, we're going to write 2x and minus 1. Since we first let u equals to 2x minus 1, so now we're bringing it back. Then this will be our final answer. This is our final answer. So now we have to move into our example number 4. Moving to example number 4. Number 4, we also have, we're moving to number 4 right now. Number 4, we also have three ratios. So we have an integral sign, and then sine, sine exponent 3x times cos exponent 3 dx. So this is our question. Okay, we have to integrate this. First thing that we have to do, we're going to expand this. We'll have sine times. So this changes into cos squared x cos squared x times cos. Now we're doing example number 4. Example number 4, we have trig ratios also. So integrating this one, you have to expand this first. Expand this first. Make it in a simpler form. We're going to have integral of sine sine exponent 3x. Now we're moving into example number 4. Example number 4 also have trig ratios. So example number 4, this is how we do it. We have to make it in a simpler form. So we're going to have integral of, my integral is big, let me write it. We have an integral of sine 3x multiply by cos. Let me put a bracket first, since we are making this in a simpler form. We're going to have a bracket. So we have cos squared x times cos x. Don't forget your dx. forget your dx. Okay, let me dx in a different color. Have my dx. So we are still continuing. We're going to change. We have integral of sine cubed x. So right now we're going to change. We're going to change this. We're going to change this into an identity which is 1 1 minus sine squared x. Back our bracket, so we have cos we should write our cos x in the black color. Cos x dx. So after we're going to multiply this by 1, then multiply this by sine squared x. We're going to have our integral sine cubed x multiplied by 1. It remains the same. We're going to have sine minus sine exponent 5. When you're multiplying same base, you're adding the exponent. Then we have we have our cos x dx. So we have sine 3x sine 3x minus sine 5x. Then we're going to let let u is equals to sine x. So we have to find du. We're going to say du is equal to differentiating sine x. We're going to have cos x, positive cos x positive cos x dx. Now we have to calculate dx. We're going to divide by cos x cos x. We're dividing by cos x on both sides. Also this side we're going to divide by going to divide cos x, and then our dx our dx is equals to 1 over cos x. We shouldn't forget our du. Alright, so continuing, we have this in our integral. We're going to write u because we said let u is equal to sine x. We're going to have u to the exponent 3 x, and then minus u to the exponent 5 x multiplied by cos x, and then our dx is equal to this. So we need to write it as 1 over cos x du. So cos x is going to cancel cos x, and then we'll be left with integral of u 3 minus u 5, then du. So integrating this, we're going to have u 3 plus 1 over 3 plus 1 minus u 5 plus 1 over 5 plus 1. Then we are adding c because we already integrated. So our final answer is going to be 1 over 4. Let me write it properly first before this. We're going to have u 4 over 4 minus u 6 over 6 plus c. And then we continue. We will have our final answer will be 1 over 4. Instead of writing u, we're going to write, let me write u then so that I can write it properly. I'll write u again. U 4. This is not our final answer. Minus 1 over 6. 1 over 6 u 6 plus c. Not answer right now. Okay, 1 over 4. And then instead of writing u, you're going to write sine. Since we said we're letting u equals to sine, so we're bringing that back to exponent 4. 4 sine cosine x, and then close brackets. Close bracket minus 1 over 6. 1 over 6. And then this is our final answer. This is our final answer. So right now we're moving to question number 5. Number 5, we have integral of sine 2x over 2 cos squared x plus 3 dx. First thing that we have to do, we have to change this. We have to change this identity like this. We're going to have integral of changing the identity. We'll have 2 cos x sine x. Sine x. I'm gonna write maybe x because I have to anyway. Over 2 cos x squared x 2 cos x squared plus 3. So we're going to let our u is equals to 2 cos squared x plus 3. Let let u is equal to 2 cos x x plus 3. So the x the x. So integrating this, we're going to have our du as, we're going to take this, we'll bring it down, then we'll have 4 cos x. Then we're going to subtract 1, then we'll have 1, then x. And then cos x, and then this one is an positive 3 is a constant, so it's going to be 0. So we're going to integrate cos x. Differentiating cos x, we'll have negative sine x. Sine x dx. Okay, so we have to calculate our dx. We're going to divide by negative 4 cos x sine x. Mistake.
sine x. Then we're also dividing on the left hand side, negative 4 cos x sine x. Sine x. So this is the value of our dx. Dx is equals to 1 over. So this is the same as negative 4 cos squared sine x. Negative 2, open bracket, 2 cos x sine x. Okay, this is the same as this. So we're coming back to our equation. We have integral 2 cos x sine x. And then we said we changed this 2 cos squared x plus 3 into u. So we're going to write for u, our u, and then multiply. We left du, it's du, and multiply by 1 over negative 2, open bracket, 2 cos 2 cos x sine x. This is the value of our dx. We're calculating dx, so we're substituting dx. Okay, so we see that we have 2 cosine x and 2 cosine x, so they're going to cancel each other, and then we'll be left with the integral. We'll be left with the integral of 1 over 1 over u. This is, you guys, 1 over u multiplied by 1 over negative 2. Negative 2, so we're going to have 1 over negative 2 integral of 1 over u. And then it's du. So our final answer, not our final answer, but we'll have this before our final answer. Negative 2. Integrating this, we're going to have in u plus c. Then our final answer is 1 over 2. Let me erase the bracket because I don't think it's necessary. 1 into cos cos 2 cos squared x plus 3 plus c plus c. This is my final answer. I hope it's clear, guys. It's negative 1 over 2. Negative 1 over 2 in 2 cos squared x plus 3. So guys, thank you for watching. This is the end of our lesson. Hope you enjoyed my video. Hope to see you next time on my next video. So guys, I gave you some homework. This will be your homework. Then after you write the answers on the comment section, then I'll check them. Then I'll conduct another class giving feedback on these questions. Thank you for watching. Have a wonderful day. Please comment, like, subscribe. Bye.